This is CCS America's series, Let's Talk Lighting, where we discuss machine vision lighting techniques and technologies so you can solve lighting challenges more efficiently in-house. I'm Emily Ting, Marketing Specialist at CCS America, and co-host of this series together with Lindsey Sullivan, our Technical Marketing Manager, who is here to share all her knowledge and expertise from her time as our applications engineer. So, first episode of the new year. Happy New Year to everybody who listens to this or watches it. We're looking forward to continuing this show in 2026. So, Lindsey, how are you feeling in this new year?
Good. I was talking to Mark, and this time last year I was coming off maternity leave. So I was very much like, what is going on? I haven't worked in months, but this year I feel much more. I know what's going on, so have that going for me. But we just had...
It's your second rodeo
my
now.
Second rodeo, 10 out of 10. We just had the flu go around the house, though, so we're just recovering, which has been fun. Except for my husband, he's still suffering. Poor guy.
Everybody's getting
Rough
it.
This year, you know.
Yeah. Anyways,
How are you?
Good. This year, I'm really hitting the ground running from a work perspective, right? Because next week we have our annual kickoff where everybody's getting together for just so much fun over 3 days. Lots of inspiration going to happen over those 3 days. And then, I'm going to the A3 Business Forum. So if anybody out there listening is going there as well, we should definitely catch up. I'll be there with Lindsey and my boss, Barbara Gagnon, who apparently everybody in the industry knows. So probably some of you do too. And then after that, we have to get ready for the technical roundtable in Denver. So it's really just nonstop action for me from January 1st.
Yeah. You also got the added pleasure of more responsibility, which is so fun. We all love that. So,
Stepping up. So. I'm too good at my job.
For real. But, yeah. So you had no choice but to hit the ground running, unfortunately.
And same with this. This is, January 6th, and I need to have this ready by next week, I think, to send out to all of our wonderful listeners. So yeah, just lots to do. So I guess we better get into it and start talking some lighting. So this one is a unique topic, which is unique solutions, and what we mean by that. So what usually happens is a customer, they can't solve an application with the resources they have. They send an application to us, and we solve them because we are amazing at our jobs. And then in some cases, there are applications that are just really challenging, and the way that we solve it ends up being really unusual, whether that's using standard solution components in a different way than they usually are used, or coming up with a really kind of DIY lighting solution. But if it works, it works. And so today we wanted to share some of those unique solutions that our app team and even Lindsey personally has been involved with over the last couple of years. And talk about how you ended up solving them. I guess it's a bit of expertise and a little bit of luck. So we have 3 applications that we're going to cover today. And the first one is one that I guess must have happened really early in your career at CCS, and it was on a Fresnel lens, which I did not know what that is. When I talked to you about, or when we were prepping for this, I thought that the lens was like a machine vision component, like it was a special type of machine vision lens, and you were like, no, that was the sample. Yeah. So I had to look it up, and it looked really cool. It's like the lenses they use in a lighthouse to help direct the light towards, into that beam. So that's really cool. It looked really interesting. I thought it was like super steampunk universe looking. It looked really cool. If you have never seen a Fresnel lens before, I suggest you Google it because they look pretty neat. But let's just start with what the customer was actually trying to inspect on this part.
Yeah, this one was definitely early on because it was when Leo still worked here, but they wanted to see...
We love you, Leo. We miss you.
They wanted to see really fine scratches and defects on it, and then dust and stuff like that as well. And so the dust wasn't actually too bad because we could just kind of do like a low angle light from the side, but it was the really fine defects that we were struggling with. Trying to make sure that it was, crystal clear. Because for the Fresnel lens, if there was a scratch or something like that, like the whole lens, it would like be amplified. So that was the hardest part to solve, was that part of the inspection.
Okay. And so walk us through kind of what happened. What were you guys testing? How did you approach it at the beginning? And I guess what didn't work in the end, because that wasn't the solution, obviously.
So I think Leo was kind of doing a little sink or swim with me, because it was one of my first applications when I started at CCS. And I had come from Keyence and had done like 2 years of solving applications with them. So it wasn't like I was new to them, but I was also not, 10 years in with experience and as smart as Leo is. So he was like, solve this. And I was like, defects on glass, backlight, perfect. And I like held it up, and the scratches were so fine that you couldn't really see them with your eye either. So I held it up and I was like, doesn't look like there's too many obvious things. Put it on there and put a backlight, and I was like, this must be the good part. And kind of was like, Leo, they didn't send a bad part. Everything's fine. And he was like, no, that's a bad part. You're doing it wrong. And apparently he knew how to do it. He was kind of, seeing what I would try. So originally,
he was testing you.
A little sink or swim, like I said. So I originally tried a backlight and then like light control film to try and like collimate it more, and like an MFU, which was like super collimated. But that didn't work, even though that's what typically works for fine scratches on backlights. So Leo told me that there's actually a specific way for solving a Fresnel lens inspection, and then him and I did that together. So honestly, he was right. It was a really good learning experience for me. Yeah.
It's like watching a little lab mouse or a lab hamster. It's like what he was doing. Where does she go the right direction?
Well, we're like taking notes. Like, how much will I have to teach this one? A lot.
Oh, Lindsey the hamster. I love it.
I'm gonna get a hamster and add it to my puffin.
You should. Just you'll have a bunch of stuffed animals in the background of these episodes from now on. It'll be like a great continuity joke of like, if you've been here from the beginning, you'll know that it was just a puffin and now there's also a hamster. We're good. Anyway, so what did end up being the right answer that Leo knew, but you didn't?
Yeah. So it's really interesting to solve a Fresnel lens. We actually took an HLV3 spotlight and had it shining straight up. But even that little, couple millimeter illumination, I don't know what's the word for that, circle, was too big. And it's actually just a tiny little pinhole. And then the size of the pinhole is like the level of the fineness of defects that you can see. So the smaller the pinhole, the finer defects you can see. So we were down to like testing like 1 millimeter, 2 millimeter pinholes, which like we don't have, that in our lab to just like set over the HLV3. So I'm sitting there with this like black like mat that's kind of sticky on the back surface. I'm like trying to cut out like a 2 millimeter hole and like trying to like, I would like cut it too big and have to like start over because you can't, and like then have to keep like this one's 2 millimeter, but this one's the 1, and we're like imaging and stuff. It was like almost the hardest part of the application after that was cutting the hole the right size. One useful thing was getting a nail and like putting that through and then pulling it out. That kind of made a good size hole. That one was easier, but yeah, so we had to like DIY the like tiny little pinhole and then put that on top of the HLV3. And then, so you put the spotlight down, then the little pinhole on top, and then that shines up into the Fresnel lens, and then that made the defects like extremely obvious, especially as we use like the 1 millimeter pinhole. And then you had to like perfectly line it up with the Fresnel lens. Like it didn't work, and then once you lined it up, it was like, oh yeah, there's everything. So it was really interesting.
So it was a really sensitive setup.
So sorry, I have a little cold remaining. I've been like snorting Afrin like it's a drug. I Yeah, it's super sensitive. So when they install it on their line, whatever, they had to make sure that it was perfectly placed and perfectly level, and everything had to be. There was like no tolerance for. Um,
So like super
yeah,
precision lighting
which added challenges to
application.
them on their end, because as much as we could be like, this is your application, like, is it realistic for you to install this and have it and set it up and work it into your manufacturing line? So they did. But
Sure. Did you try like other larger sizes besides 1 and 2 millimeters?
yeah, it's kind of the same thing we do with like testing the light working distance at different heights to see what changed. I think we started from 4, 3, 2, 1. I think we definitely tested like a large variety to see which one was the best. And I think 1 was almost too fine, and 4 was not fine enough. So we ended somewhere in the middle there.
Can you explain a little more of like how that, like what the pinhole is doing and like I guess why it's at larger sizes it was not fine enough and at 1 it was too
Yeah,
fine?
my initial like thought, back at the time was I was like, oh, we're changing the collimation, and Leo was like, no, not really. I was like, okay, teach me more. He's like, I know. So it's limiting the angular spread. So when you had, this is like the surface of the HLV3, and then we limited it to this. So like the bigger the hole, the more it could spread out. And so we were, 4 millimeter down to 2 to 1. So when we limit that angular spread, and then when it hits the Fresnel lens, it redirects the light. That's because like it's a lens. That was kind of part of the problem, is the lens itself is redirecting everything. So having the more narrow angled spread redirected the light in such a way that it would disturb the controlled light field, and then would make the defects more or less present. So just by making that angle lower, the way it hit the lens would do the more fine defects. I also won't lie, this application was 7 years ago. So like when Leo explained this physics to me then, I was at the time I was like, yeah, perfect, but like my perfect recall 7 years later isn't super great.
No, it's all good. I wonder how he
Leo
knew
knew
about this, like what
everything.
textbook.
I never had a question that Leo couldn't answer. It was insane.
It would be like I don't know how good his 7 year recall is, but it would be interesting to have him on this show to talk about that because it's really interesting because the sample itself is its own lens basically that's refracting the light and it's all lighting is already hard enough when you have like one lens on the camera getting light from a not lens sample. So yeah, that sounds really
It was.
tough.
Honestly, if it was just me, I wouldn't have solved it at the time. Or I would have been like, this is it. All your parts are great. Good job. 10 out of 10 manufacturing.
Yeah. No, but I looking at the pictures of the lens because it has all those like ridges in it.
Mm-hmm.
And that's like where the problem comes in. But yeah, really cool solution. So yeah, if anybody out there has to do a Fresnel inspection right now, like we just solved it for you. You can thank us later
Buy an
if you wanna.
HLV3.
If you wanna, yeah. If you want to send us a little gift, we'll take it.
PO.
Yeah, buy our HLV3 is the best way you can thank us, probably. Not to pitch you too hard in the middle of this, because this is supposed to be education, which is why we should probably move on to second application, which was a vial inspection, which I think I know you didn't work on this one, but you're probably going to have to expound on it a little more for us because there was a period I remember where like every application we got was a vial application and they were all the same, but they were all different. So what was it about this application in particular? What were the defects that they were trying to look for?
Yeah, this I remember that was so funny because you would think like you solved one vial, you solved them all, but apparently not. And so this one, they were looking at like bubbles and glass and defects, within the glass. Kind of honestly, really similar inspection to the Fresnel lens, making sure that it was, intact and didn't have bubbles and scratches and stuff like that. But similar to the Fresnel lens, when the AE was testing it with just a plain backlight and even collimated film, it wasn't getting the fine enough defects that he knew were there and he wanted to get, and the customer wanted him to get. So that, yeah, just standard, just a few, and even with the light control film and stuff like that, it wasn't really working. And even the MFU might have been something to try, but the field of view on that one was so limited that it wasn't possible to do the whole vial with just that small field of view the MFU offers.
And were there like any restrictions on it that made another, standard light, like maybe it could have worked, but it didn't because the light could only be installed like this close to the sample, or there was no room for another light?
I don't think so. I didn't work on it, but I don't remember the AE telling me that there was anything like that of why. Because a backlight had to be used, and adjusting the light working distance would have just changed the collimation. But the light control film was kind of doing that. So I don't think, long story short, I don't think so.
Okay. This is just like side question related to like vials in general. Does like the fact that it's a cylindrical shape have any impact on like how well a backlight works on, a cylindrical sample versus one that's like, a flat glass plate or something?
Yeah, it does actually, because when you have a flat glass plate, it's one plane, and so the light just goes through and is refracted all the same. But when you have the cylindrical sample, the edges where the glass is kind of it's like thicker because it's rotating around. You kind of end up seeing like a black line instead of just straight through like you would for a glass plane. So if you're doing a vial on a cylindrical sample, you have to actually either have multiple cameras taking pictures or rotate the sample, or you're going to miss essentially the edges of the vial. If there's a defect there, it's going to just blend in with what the side of the vial looks like. So, yeah, the way everything gets refracted and stuff. Lots of physics.
Yeah, so even the standard vial application is a difficult one to do with standard lights, but this one required a unique solution. So tell us about that.
Yeah, Austin, AE Austin, yeah, shout out to you. This was a really creative solution. I remember when he, was talking about it, and he was struggling with it. I was kind of like, good luck, try some things, throw some stuff at the wall. I don't know, I've given you all my ideas. And like a couple weeks later, he came to me and was like, I solved it, and like incredible. He used the zebra mask, which, if you don't know what that is, that's an FELux product, and it's just like black lines. It kind of looks like the transparent sheet. Remember in elementary school when they would like write on the transparent sheet and put it on a projector and like shine it up, and that's what we took notes with? Yeah.
I feel like we're showing our age,
bit.
right? Like I don't know if does Gen Z know what we're talking about?
Chance,
They're not.
no.
Like there's gonna be Gen Z people listening to this, or maybe it'll be on YouTube.
But yeah, so back in 1997, there's like those little transparent sheets. So it's like one of those, and she's got black lines on it. And what it's used for is putting it on like a flat dome light and shining it onto like paint or something like that, or like a really shiny flat surface. And then wherever the lines like deviate, that's when you can tell there's like an issue with the paint, whether it's a scratches or dents or, just texture there. And so you're not actually looking at the paint itself, but you're looking at how straight those lines are. Well, so he utilized the zebra mask, but instead of using it to like see texture on something, he used it to kind of like act as like a phase object and adjust the light and control the light such that it made all of the foreign material or small tiny defects much more clear. So it was really creative how he did it. The exact way he figured it out, I'm not 100% sure. For all I know, he was sitting there and was just like looking around at every accessory we had and just like tried it and then put that one down and it worked. He was like a big huzzah moment. That's what I'm assuming happened. But yeah, I was really impressed with him coming up with that solution.
Yeah, so there's the zebra mask for like the FLux lights, and then I think CCS also the LFX has the pattern version, which similar, it has lines printed on it. I'm not sure if that would have worked for that application because in principle it's the same thing, although I know the zebra mask on FLX is a lot thicker lines than the LFX3
Yeah,
pattern.
I don't know for sure if that would have worked because the way that the LFXV worked, it's like the patterns were on like the dome light part of it, the acrylic plate, but when it shines down, it was shining like a dome light essentially, but like putting the zebra mask on the backlight was like blocking light at every like pattern, and they were thicker too. The zebra mask was.
Yeah.
So I think it would not have been the same. I think the LFXV would have acted more as a backlight versus blocking the light like the zebra mask did. But yeah, that is a nice product too as well.
Yeah. So why can you tell more about why the pattern helped highlight those defects instead of make them harder to see?
Yeah, I'm not, of what my thought is on why that worked well was, glass has, phase objects, and a zebra mask can create a structured illumination, and then that intentional spatial intensity with intentional spatial intensity gradients. So they essentially, zebra mask had a structured illumination to it, and then that will distort or shift the pattern, and then that will kind of create let's see, the pattern, oh gosh, I don't know how to like explain this very well. In my head it makes perfect sense. So all right, the pattern on the zebra mask increases the spatial frequency, which makes the distortions easier to detect. Is my guess. Honestly, I didn't think too much into it of like, oh, like, why is that working? I was just like, wow, incredible, it works. You solved it. Like, send it along. But the structure that it provides is giving the refraction of the vials and stuff like that was all kind of working together.
Yeah. Do you want to just quick explain what you mean by structured light because it makes sense to us? And I think sometimes it's like it's common knowledge to us, but somebody not super into machine vision lighting might be like, what is structured light compared to, the other types of lighting that you usually see in machine vision?
Yeah, so usually when we say structured lighting, we talk about like the FE lace, which is like projecting a pattern or something like that. Like most of the time when we say structured light, we're referring to that. But in this situation, we're also kind of blocking it with the mask. So it's essentially, gosh, that's a wonderful question. It's essentially when you're taking the light and making it illuminate in like a really specific way, like a laser of like a grid or something like that. It's kind of the same idea where we're kind of blocking it and illuminating in a specific way.
So like if there's like direct bar lights, for example, and then there's structured light where it's shining direct light, but maybe, like you said, in a kind of pattern almost, in like a very clear pattern.
Yeah.
That's what I'm here for.
Take
Is to take the stuff inside your head and make it kind of understandable. Hopefully I made it kind of understandable.
You did. You're doing your job wonderfully.
Yeah, it's either me or ChatGPT, I guess.
ChatGPT only works so well. It's definitely not as good as Emily.
Aw, thank you. I guess the AI overlords won't take my job just yet. But anyway, so I think, the first application and this application both were like, glass samples in a way that had, that caused a lot of trouble because they're made of glass. The material in itself is causing extra challenges. So were there any trade-offs in this application where because of the structured light, maybe it was, again, a super high precision type of application with no tolerance?
Yeah. So because we were kind of blocking half the light, you didn't get like a perfectly uniform vial. Like half the vial was covered with black and the other half was illuminated, but you could see all the defects. So the inspection area that we could see wasn't really the whole vial anymore. It was kind of just a sliver. So in order to inspect the whole vial, we had to take multiple pictures of it being rotated. So it was, you got to see more of like what you were looking at. You got to see smaller defects, but you could see way less. So you had to rotate it more frequently and take more pictures instead of just like 2 or 3.
Mm-hmm. Got it. Yep. It's always food for thought, right? Is if you want to take an image of the whole sample, sometimes if you want to see what you want to see, you have to make sure it rotates or moves around. And this is like what you always talk about is like a common pitfall in machine vision lighting, because people don't have the rest of the system designed to do that. It's like one image trying to capture everything, and that often doesn't work.
Yeah.
Okay. Now on to the last application, which you're gonna have to tell me more about this because you said film on gray pads. I'm just like, what industry could this possibly be for? So tell me what was this and what were you trying to inspect?
Yeah, I don't remember the industry, but I just remember it was like a metal part that had like a really textured background, and then it had these tiny little like foam gray, like shiny foam gray, like really thin pads, and then on top of those was like essentially like Scotch tape, that really thin material with like a slightly blue tint to it, like a really transparent blue Scotch tape. And they needed to see if the blue Scotch tape, for all intents and purposes, was on the gray pad or not. And this one seemed really easy. Like when they explained it to me, I was like, got it, afternoon. We'll be home by dinner, whatever. And I was humbled very quickly on that one. Because I thought, like usually when there's like a color, it's like blue and gray. I was like, great, we'll put a red light or like a blue light, depending on how light the gray is. That'll darken it or brighten it, and then it'll be super obvious. But the downside was that the film was so transparent that even though there was a blue tint to it, using a blue light or a red light didn't create enough contrast to note if it was there or not. So then it was like, how do you, make a film there if the color won't detect it? I was trying to pull out all the stops of, is it reflective? Is it not reflective? Like it was just matte and diffuse enough, like Scotch tape is, that it wasn't shiny, so it wouldn't like reflect it. While they were both the same reflectiveness, and so it was just kind of trying a bunch of things, and I wasn't sure that I was going to be able to solve it, if I'm being completely honest. So yeah, I kind of was really defeated. And this is when I lived an hour away from the office that I had to go down to because we moved. And I was like, I don't want to have to like drive back to the office tomorrow because I didn't solve this application. So I was like getting down to the wire of like, well, we'll solve it. No. So
it's 11:55.
Yeah, I want to go home. Yeah.
All right, so at 11:55, what did you discover?
Like 3:20.
What did you discover in the wee hours of the day, of the night that solved it?
So once the color or the monochrome camera with the blue light didn't work, I actually did try color camera because I was like, okay, like we're seeing color, we're detecting color, but again, it was still too transparent to be reliable. And another thing I didn't mention was the background. I said had a lot of texture to it. That was causing a problem too because it would be like really reflective and stuff like that.
Causing a lot of noise.
Yes, exactly.
In the surrounding area.
Exactly. So that was causing a lot of challenges as well. And when I had the color camera on and I was like, I'm getting a lot of noise, I should like cut this glare out. And I was like, what cuts glare? A polarizer. Which like, I know that polarizers work on monochrome cameras, but like I was just like trying everything. So I stuck a polarizer on to cut glare, and then that ended up solving it. Because when you put a polarizer with the color camera, it doesn't just cut the glare like it does the monochrome camera. It creates like a rainbow, on some materials, it creates like a rainbow texture to it. And so when I put this polarizer on the color camera, the film itself had to turn like rainbow. And then the gray pads didn't have any rainbow on them. So then we could check that pattern, like is there a rainbow color or is there not? So then it became super easy. And it was like a really cool, like stumbled upon it because I was trying to solve a different part of the application to see if that like got rid of the glare, but it just ended up solving the whole thing, which was really cool.
Yeah, so was it because the gray or so the gray part was matte, the gray foam pad was
Mm-hmm.
matte, and that's why it wasn't creating a rainbow?
Yeah, so the gray foam pad was exactly, it was, okay, so when the polarizer was hitting the film, um, it okay when it sends off different wavelengths, right? So when you have a white light and it's
Yeah,
reflecting with there's polarizers and stuff like that, it's sending out different wavelengths of different colors. And when you use it with a monochrome camera, it just kind of averages them all, and so there's not really a big difference. But when you're using it with a color camera, it can capture all of those colors, and that's why you see that kind of rainbow effect. So the
sure.
thinness of the film, where it was reflecting on the top and on the bottom, was kind of causing it to interfere with each other, and that's where you got the rainbow effect. And then when you get to the foam pad, that was so matte and diffuse that it kind of just sent it all in like one direction, didn't have anything interfering with each other, so it just kind of didn't have that same effect that the thin transparent film had. So that's where we were getting that.
Sure.
Yeah.
Okay. That's
Yeah.
interesting. It's like when scientists 500 years ago, knock something over on accident and make a discovery that lands them in the history books
Pretty much invented
forever.
the penicillin here, you guys, just so you know.
Yeah, so I mean, like you said, polarizers, you usually use them with a monochrome camera. I think we said in a previous episode, like, you don't use polarizers with a color camera. That's the point of them is to use them with a monochrome camera. So
Not
I
always.
guess why should some yeah, always 100% of the time never try
Never
it.
try it.
Never try it with a color
Yeah.
camera. That's not really the case because my question to you would be like, when should you try and consider like trying this wild, color camera polarizer combination?
Yeah, it's funny because it's actually like a decent phenomenon that happens to where CCS invented a product that like does this. We can't sell it in the United States for some reason, but if you're not in the United States, you can look into it. But like, so it's not like as much as I want to say I invented penicillin. This is nothing new. Very shortly after this dedicated product that pretty much did this was like around, and I was like, oh yeah, that.
You discovered it
Yeah,
independently.
therefore I should get credit. um, Honestly, this was a moment of desperation and accident. So, like, when you get to that point, try it. But it's really good if you're using, like, the film, like scotch tape, film, things that kind of seem like they have a little bit of polarization to them. That would be good to try for that kind of stuff. But honestly, if you're at your wit's end and you're like, I'm not really sure what to try, like, give this a go. It might not work, but it might work. So, like, it's more likely to work in a scenario like this with some type of film on it, but honestly, it could work for something else too. You never can tell with machine vision. The best and worst part.
Definitely. Which that those three applications all like sum it up, right? It's fun because you come up with some really like weird stuff, unique stuff, but it's difficult for just any engineer to think maybe we should try
Mm-hmm.
this or maybe this could work. So to kind of wrap up this episode, do you have any advice for our listeners of, maybe trying one of these solutions doesn't solve their exact application unless they're working on a Fresnel lens right now for
Yeah.
some reason, in which case, again,
Give us a
HLV3,
call.
buy it from us. Thank you. You're welcome. Yeah, but yeah, should is there any knowledge or advice you have to give people of like so how they could hypothesize what kind of unique solution to try or you know what they can do in their testing lab to potentially discover one of these unique solutions that will work for a particular challenging application they
Yeah.
have.
Get a PhD in physics in your spare time, and then you'll learn it all. Or In my situation, marry somebody with a PhD in physics. Just kidding. It's in chemistry, but maybe I could translate it. No, honestly, most of the stuff came from desperation and luck, especially the last one. So have that. But don't sleep on accessories because not really the first one, but the second and third were just accessories that we had that we use them in an unconventional way. So, you've got your lights. Most people make sure they've got the lights in the right colors, the right sizes. But the accessories that go with the lights they're made for a reason. They have a purpose. They have a use where they will improve the light to do what you need to do. So make sure you have them. And then when you're really stuck, like try it on something else. We used to have, we still do, but I used to use a lot of like a big sheet of light control film, and I would like cut it to whatever size light I needed. Which, fun fact, privacy film from 3M or a company like that you put on your computer screen is pretty much light control film. So we would just buy that and keep it in the lab and then, cut it to whatever size light we needed, and then we could use it for that, and then, would recommend a custom product of light control film for that light, whatever. But yeah, make sure your accessory game is strong and try it, and don't be afraid to venture out. And even if you think something's silly or this won't work, make sure it doesn't work. Don't just assume, because you never know.
As long as it doesn't cost too much money, you'll probably 3M light control film is one thing. Some $500 gadget. I don't know if your boss will say yes to that right away, but
if it helps,
yeah.
I don't think any of our
even
accessories
for the first
$500.
Yeah, even you said the first one didn't really have any accessories, but you had to put it on. Essentially, was like a protective cover, right? The black dot on a protective cover.
We just put it right on the HLV3. But we had to make up we had to have that matte sheet that we could cut little holes into and cut it to size and stuff like that. So even so, we had to have an accessory in the lab to solve that application. Yeah, having matte sheets of little black felt sheets were useful to cut down glare.
So in summary, have a wide range of optical accessories, have even the non-visible UV, IR, those sometimes come up with a unique solution. And yes, I guess try monochrome and color cameras, because who knows what's going to happen.
Yeah, I did try UV on that Polarizer, or that gray pad application, and I was like, this'll work. Did not. Did not work at all.
But you found a solution in the end, which is pretty impressive.
I didn't have to go back the next day.
Amazing. Yeah. So thank you for, again, sharing your experience from way back in the day. No, it's been a while as I think about it. That was when you had just joined the company, and then I joined a little bit after. Mm-hmm. And then I went off to Japan and didn't see you guys for 3 years. But yeah, so you clearly did a lot of amazing applications back then, and obviously Jason and Redo, our two engineers, do a lot of solving of amazing applications now. Mm-hmm. So if anybody listening, they don't have all the optical accessories to test this stuff for some reason, we do have them. So free application evaluations. You can send us your sample and say this is what you're trying to do in this inspection, and our app team tries to solve it, whether it's with something standard or by combining a color camera with a polarizer. Exactly. So yeah, good episode as always, Lindsey. Look forward to doing more of these with you this year. So yeah, stuff we have coming up. Technical roundtable in Denver, Colorado. That's the first one, and it's happening February 5th. So you can go to our website and register. And then we have a few more happening the rest of the year. We will be at Automate in June. That is our, big trade show of the year. It's basically the only reason that Lindsey and I are kept on for a job, is to take care of managing all that. That is I don't know, 80% of our value to this company.
Everything else they kind of let us do, they're like, sure, go for it. You want to make a podcast?
Yeah, it's the trade show that's like, make make sure that we have everything we need for these 3-4 days. And yeah, if you're going to be at the A3 Business Forum, hopefully I get to see you there. But yeah, if you learned something new about machine vision lighting today, please give this video a like and subscribe to our channel. And you can also follow CCS America, Lindsey, and myself on LinkedIn. Feel free to send us your questions or topic ideas for this series, especially because we have the whole of 2026 ahead of us to talk about this and that. Yeah, we'd love to hear it. And yeah, thank you for listening, everybody. See you throughout the year.